Yesterday we talked about what? Solving systems of equations, right? Okay. So there was a little bit of, not really confusion, but maybe not fully understanding. So let me ask you this question real quick. Because one of the first things we talked about was, what's a system, right? And for the most part, most of you I think were okay with it, but let me see if I can help just a little bit more with that. Okay? What is the circulatory system? What's part of that? Heart, blood vessels, veins, capillaries. Those are my favorite. Okay, so what's the skeletal system? Bones. Okay. What about the digestive system? Esophagus, stomach, intestines. So if we're talking about that kind of thing, what is a system? Group of things working together for a common goal, right? So what is a system of equations? I mean, isn't it the same kind of thing? Two equations working together, right? Or I guess I should say two or more, right? Because there could be more than two. Two or more equations working together. Now, there's not really like a common goal so much as there is a point of intersection, right? And that point of intersection is our solution. Do we always have a point of intersection? No. Sometimes if we're talking about lines, sometimes they're parallel. Or sometimes we're right on top of each other, right? That's really a system because every point's a solution, right? Okay. Does that help you understand what a system is a little bit better? Maybe? Okay. So what happens if our system looks like this? Dang it. What happens if that's what our system looks like? Is that a problem? No, it just has another variable, right? Okay. So, could we graph this system? Yes, we could. It would be a system in 3 dimensions, right? X and Y, that's just a line, right? X is just a point, X and Y is a line, X, Y, and Z is what? It's like a plane, right? We got different, God bless you. We got different stuff going on, God bless you. So, think about if I have planes, right? If I have 3 planes, here's 3 pieces of paper right here, 3 planes, okay? Let me zoom out just a little bit for a second. If I've got 3 planes right here, if these 2 planes intersect right here, what does 2 planes intersecting create? A line, right? What if I had another plane in here this way? Where do they intersect at? Is it? Well, these 2 make a line, right? But where do all 3 of them intersect? Oh, at a point. So how do you think we would write that point? X, Y, and Z? So like this? What do you think we would call that type of point? What did we call it when it looked like this? What else did we call it? Starts with an O. R. D. Ordered pair, right? What do we think we're going to call this? Very close. Okay, it's called an ordered triple. So here's the rule, all right? The rule is however many variables you have, that's how many equations you have to have at the very least to solve the system. Okay? So yesterday our equations looked like this, right? So how many did we need to solve the system? 2. Today our equations look like this. How many variables do we have? 3. So how many equations do we need to solve the system? 3. Okay? Just for the record, when I was in college, I had to do a senior project as a math major. I did my senior project with stuff like this because to me this is a giant puzzle. And word problem wise, like we created a situation where Hardin Simmons and Howard Payne were going to play baseball against each other. And we knew the possible pitchers and we knew the possible hitters. We knew the batting averages of the hitters against each pitcher. So I solved a 9-variable system of equations to say if these people were pitching, who should hit? Or if these people were hitting, who should pitch? Okay? 9 variables. So how many equations did I have? 9. Guess how long it took me to solve it? Almost all semester. Partly because I kept missing a negative sign. Those are the bane of my existence, is negative signs. All right? But I got it solved, and I presented it, and I did a good job. The professors were intrigued. Okay? I'm just going to ask you to do 3 variables right now, if that's all right with you. Okay? So, can I do an example for you? All right. So the way we're going to solve these today is by substitution. That's what we did yesterday, right? So it's similar to what we did yesterday, but not exactly the same. Now, before we even start this question, I need to point out the fact that I wrote something on a purposeful way so we could have a quick discussion. Okay? Look right here. Is this a 2 or a z? Are you positive? Is this a 2 or a z? Are you positive? So I need you to understand that sometimes when I'm doing systems of equations problems, I get excited and I go fast. And so to avoid confusion, I will always cross my z's. Okay? So if you see something like that, that's a 2. If you see something like that, that's a z. I try to take my time and make my 2's look like this. But sometimes I just get excited. Okay? So just in case you have any questions. I'm not asking you to cross your z's. I'm telling you what I do. Is that fair? Okay. So here's the system. Okay? Here's the system. And if we're solving by substitution, what does that imply? What does substitution mean again? We're replacing, for sure, right? Replacing a substitution. Okay? So what do you think I ought to do to start? Well, it already tells me that x equals 4, so that's a super big bonus, right? What could I do with x equals 4? To the bottom one? Oh, the second one. Why would I plug it into the second one first? Oh, if I plug it into the second one first, 4 plus y equals negative 6, I'm going to know what y equals, aren't I? So if I subtract 4 from both sides, I get y equals negative 10. And how many variables am I trying to solve for? 3. 1, 2. Haha, I only have one more to find. Which one is it? So what should I do to find z? Plug what into the bottom? Oh, everything I know, right? Okay. So 4 times 4 minus 3 times negative 10 minus 2 times z equals 26. 4 times 4 is 16. Negative 3 and negative 10, 30. Minus 2z equals 26. (16 and 30). 46 minus 2z equals 26. Subtracting 46 from both sides gives me negative 2z equals negative 20, right? Dividing both sides by negative 2 gives me z equals... Uh-oh, what did I do? No, it's my own fault. Can I fix something real quick? I just know what the answer is, and I know it's not supposed to be that. Okay? When I wrote down the problem, I wrote it down wrong. Guess what I messed up on? A sign. That should be positive 2. So that should be positive 2, and that should be positive 2, and that should be positive 2. So when I divided by, I should have only divided by a positive 2. Please forgive me. But also please understand how easy it is to mess up even just copying the problem. So I guess I could afterwards use this as an example. I didn't do this on purpose. It was an accident. Okay? But I'm going to use it as an example of why you need to pay really close attention when you're copying down your work. Is that fair? Okay. All right. So what is the answer? Wait, this isn't the answer? You have to put it as an order triple, right? How do you know what order everything goes in the order triple? Oh, so alphabetical? Okay. 4, negative 10, negative 10. Good? Questions? This is the solution, right? How could we be positive that that was the solution? I could, right? I could plug it in. 4 equals 4. Okay, good. 4 plus negative 10 equals negative 6. Okay, good. Now I know that one's going to be right because that's what I just used to solve it, but just in case. 16 positive 30 is 46. Minus 20 is 26. Good? Shall I do another? Yes. Absolutely. I'll be happy to. Because guess what? They get a little harder. Okay? Okay, I know I copied down correctly this time. Why is this one more difficult? It doesn't have a variable already solved for us, does it? Okay, but they were nice enough to give us the second equation. What do you notice about the second equation? It only has 2 variables. And if we're solving by substitution, what do you think we might want to do? I want to start with the easiest one, right? So let's look at this one. Look at this equation right here, and what do I want to do with it? So solve for a variable. Now, Wes wants to solve for z. Does anyone agree with him? Okay, so even though z is negative, you still agree with him? Yeah, I do too. Because if we try to solve for y, I'd have to divide everything by 5, and that would give me a fraction here and a fraction here, wouldn't it? I don't like that. So let's say 5y minus z equals negative 31. All I did was copy it over there so I can put my work underneath it. Okay, you can do that or not, just it's up to you. I'm going to subtract 5y from both sides to get negative z equals negative 5y minus 31. Is z solved for? Okay, this was an issue yesterday for some people. They thought z was solved for. In order for z to be solved for, it has to be all the way completely by itself, right? Divide everything by negative 1. Z equals what? Okay, 5y plus 31 or 31 plus 5y. Whichever way you wrote it down, it's the same, isn't it? Okay. Now the thing is, what do I do with it? Where? Top one? Oh, why do I not want to put it into the middle one? That's what we already used. So that's the only one I can't put it in. Okay? So did you say top or bottom? Bottom, okay? X plus 3y plus 2 times z, which I know is 5y plus 31, equals negative 21. Everybody okay with that so far? So x plus 3y plus 10y plus 62 equals negative 21. Okay so far? Now what? Combine the y's. Okay, that's what you want to do. That's fine with me. We'll combine these two y's. X plus 13y plus 62 equals 21. Am I done? What's negative? Oh yeah, let's subtract 62. So x plus 13y equals, correct. Did that help us? It did. It did, right? Remember what I said at the beginning? Back over here? If I have 3 variables, how many equations do I need to solve the system? 3, right? 3 variables, 3 equations. I have how many variables now? 2. What do I need? I need another equation with just x and y. Okay? I have z. I know what z equals, but I don't care about that right now because what I have is an equation with just x and y. That means I need another equation with just x and y. How did I get this equation with x and y? I plugged z into the last equation. How do you think I might get another equation with just x and y? Plug z into the first equation, right? Okay, so 2x minus 2y plus z. So 5y plus 31 equals 3. Everybody understand where that came from? Okay. So now I'm going to combine my y's. 2x plus 3y plus 31 equals 3. And then subtract 31. 2x plus 3y equals negative 28, right? So now I have 2 equations with x and y. Is that good? It's very good, right? Because now I have a brand new system, don't I? So this is just like yesterday, isn't it? So it's almost like it's almost like I start all over from right here. Put it back here, please. So I start right here, right? What do I do here? So I want to start all the way over again. Now some people like to write this here. Some people like to do this. X plus 13y equals negative 83 and 2x plus 3y equals negative 28. So it's like they're starting all over with a brand new system. They just like to rewrite it to a new space. I don't care if you do that or not. In fact, if you look at my notes, I didn't do that. I just started with these 2 and went from there. Okay? But if you want to start here, that's fine. So what you're telling me is you want to isolate x? You want to isolate that x right there? How would I isolate that x right there? Subtracting 13y. So you're telling me x equals negative 13y minus 83. Is that correct? Now that I know what x equals, what do I do with it? Do I mess with these things up here yet? No, I'm ignoring that still, aren't I? Now go here. So I'm going to take this x and plug it in right there, right? So 2 times x, which I know is negative 13y minus 83, plus 3y equals negative 28. distribute, distribute. Negative 26y minus 166 plus 3y equals negative 28. I got a y term here and a y term here. What do I get when I combine those two y terms? Negative 23y minus 166 equals negative 28. Good. Adding 166 gives me negative 23y equals 138. Dividing both sides by negative 23, y equals Guys, I'm not a calculator, I'm your teacher. Yes, I finally found part of my answer, right? I finally found what one of the variables equals. What do I do with it now? Where? So I probably want to go here first, right? I want to go here. X equals negative 13 times negative 6 minus 83. X equals 78 minus 83. So X equals negative 5. Now we're in all of this mess. Where should I go? Right here, right? That I solved for from the very beginning? Yeah? So if I plug in y, okay, which one was y? Oh, negative 6, okay. So z equals 5 times negative 6 plus 31. So negative 30 plus 31. So what's my answer? Negative 5, negative 6, 1. Whoop, sorry. Boy, that was a mess, huh? Now, was any of it hard? None of it's hard. There's just a lot, right? There's a lot of little steps. How many different places could we have made a mistake? A ton. Okay, so did I go fast? I did not. Even I don't go fast on these problems. Okay? It's also why I didn't give you very many for homework, because I know they take a lot of time. Okay? In all of your homework problems except for one, you're given an equation like this to start with. Okay? Guess what I'm not going to do on that other problem? I'm not going to show you how. Yeah, I want to see how you handle it. Okay? I may put something on Instagram tonight to help out with it, but I'm not going to start with instructions on it. I want to see how you handle it. Okay? So talk through this with me real quick. Okay? If I'm given an equation like this, what do I do first? Solve for a variable. Once I solve for a variable, where did I put this variable into? Not only one of them, but both of them, right? Both of the other two equations. And that gave me a brand new system. So between one of these two, I solve for a variable, substitute it in, and that helped me solve for one of the variables. I plugged it in, substituted it in to find the other variable. Then I went back up to the top and substituted it in here to find the third variable. Does that make sense? Okay. Any questions on this?